Hello everybody. I'm going to show you something graphically that you need to understand, and it'll be useful for you in the long term. Okay, what am I going to show you? Well, here's a function. This is for your homework. Y equals x squared, and it's defined in the interval 0 to 2 pi, and they tell you it's periodic. That means whatever is between 0 and 2 pi is repeated to the right and is repeated to the left. Now, when you do your evaluation of Fourier series to calculate A0, 1 over 2 pi, integral minus pi to pi, etc., you have to integrate minus pi to pi f of t dt. So what we're saying is pi is somewhere there, minus pi is somewhere there. You're going to integrate from minus pi to pi. In the region 0 to pi, y equals x squared. Easy enough. But in the region minus pi to 0, y will be, probably 2 pi plus x squared. It's a little bit more complicated. You have to think it through. What is this function here? But nonetheless, the integral is the area under the curve. Is the area under the curve. You know the integral is that. Now, what I'm trying to show you is this can be done easier as integral 0 to 2 pi f of t dt. 0 to 2 pi. Why? Because the function is simply y equals x squared in the region 0 to 2 pi. It's given to you. Y equals x squared. You don't have to worry about y equals x squared here and here is something like 2 pi plus x the whole squared or something like that. You don't have to worry about that. You don't have to break up the integral into two pieces because the functional form is different here. 2 pi plus x squared, here it is x squared. To the entire interval, y equals x squared applies. So it's easy to calculate integral 0 to 2 pi f of t dt because simply say it will be t squared dt. Very easy to integrate. But look at it like this. When you integrate 0 to 2 pi, it is the area under this curve. And if this is pi somewhere here, first you get this area, which is exactly the same as that area, 0 to pi under the curve y squared. Then you get this area, and if you look graphically, that area is exactly the same as what you had to the left of the y-axis here. That's exactly the same. So graphically, you know the sum of these two areas, which is what you want to evaluate, is the same as the area that you get if you integrate 0 to 2 pi. Now let's go a little bit more complex. Come on, guy. There we go. This is again y equals x squared. Y equals x squared, yes. Now this is sine of x. You have to calculate for finding b1, for example, the question b1, 1 over pi, etc. Integral minus pi to pi, f of x, let us say, sine of x dx. I know I used f of t and x interchangeably. You have to evaluate that integral. The product of f of x times sine of f of x is x squared. The product of these two looks something like this. And you're required to evaluate from minus pi, which is somewhere there, so maybe somewhere there, to plus pi, which is somewhere there, in that region. And I will try, I'm not perfect at this, to draw a line for you. A minus pi might be something like that. And plus pi may be something like that. Oh, well, let me draw it. Something like that. And the 0 line itself, y equals 0, is over there. So integral minus pi to pi of this function which is y equals x squared multiplied by sine of x, is this negative here, and this positive here, and that's it. The sum of these two areas is that integral. If I were to try to integrate 0 to 2 pi, at 0 it'll be like this, that'll be the line 0. 2 pi would be like this, something like this, approximately like that. And y equals 0 line is the same as before. That's y equals 0 line. Integral from 0 to 2 pi would be this positive area and this negative area. This negative area matches this. I didn't draw this properly, I'm sorry. This positive area matches that. Integral minus pi to plus pi, the net effect would be the areas under the curve are the same as 0 to 2 pi, equals integral 0 to 2 pi f of x sine of x dx. Why am I showing you this again? Because 0 to 2 pi, f of x is simply x squared. If you do minus pi to pi, then f of x is different, less than 0, greater than 0, it's x squared. You have to break it up into two integrals, and you have to find the function here for f of x. That's the reason why integrating 0 to 2 pi is easier. Again, any time you can integrate over the period. You can integrate from pi to 3 pi. The width is 2 pi. You can integrate from 7 pi to 9 pi. The width is 2 pi. You can integrate from minus 0.5 pi to minus 3.5 because the width is 2 pi. Minus 0.5 to minus 2.5 pi. The width is 2 pi. As long as the width is 2 pi, you'll get the same answer. Again, to etch this in your brains permanently, here's the last example. Here's y equals x squared again as before. This is cosine of x. Let me draw the 0 line, then it'll be clear that this is cosine of x. When x equals 0, cosine of x is 1, etc., etc. And when x equals pi, cosine of x is minus 1. Now, if I multiply f of x by cosine of x, you need this to calculate a1, integral minus pi to pi, f of x, for us it's y squared, 0 to pi, 2 pi, cosine of x dx. That product fx cosine x looks like this funny shape. Let me draw the 0 line for y. So it has a tiny positive area, a negative area, and a positive area. If I go minus pi to pi, let me draw minus pi. It's probably this. Minus pi, I don't know, probably then. And plus pi would probably be that. So the integral, which is area under the curve, this is 0, would be this negative value, this positive value, slight positive value, and a negative value. That is the area under the curve. That's integral minus pi to pi, fx cosine x dx. If I were to draw the same thing from 0 to 2 pi, 0, 2 pi. And for reference, we draw y equals 0 again. So integral 0 to 2 pi, which is from here to here, is a small positive area which matches that small positive area. And this is this negative area, and let's see, pi is somewhere there, negative area, which matches that negative area. And then there's this negative area, which matches that negative area. And there is this positive area, which matches that positive area. Graphically, we see integral minus pi to pi fx dx equals integral 0 to 2 pi f of x cosine x dx. So it doesn't matter if you apply by cosine x, or if, to generalize, integral minus pi to pi f of x cosine nx dx, any n, equals integral 0 to 2 pi f of x cosine nx dx. So you see what I mean? The width must be 2 pi. The width of the integration interval must be 2 pi. You can go from minus pi to pi, 0 to 2 pi, from pi to 3 pi, from 0.5 pi to 2.5 pi. It doesn't matter. As long as the width is 2 pi, you'll get the same answer. Again, this is useful for you in the homework, because when you integrate from 0 to 2 pi, f of x is simply y squared, x squared. Since it's x squared, is only one integration. Whereas if you integrate from minus pi to pi, it's two integrations. Here it is x squared, here it is something else. So you have to integrate two separate integrals. Okay? I thought this will be useful for your homework. Thank you.